Okay, today I'm going to do this. Let's say I have this cubic equation, x3 plus 4x squared. Okay, you want to find the x. Okay, first of all, show that the equation has a root that is x, and the x lies between 1 and 2. Okay, this one we have done it. So what we do, we write it into a function. Okay, that means we try to find f1, that is the remainder. Okay, last time when we do the remainder theorem, so you get the remainder is negative 15. That means x minus 1 is not a factor, that is x is not the root. X minus 1 is not the factor, so x equal to 1 is not the zeros, not factor. Okay, this one you remember. So x is not 1, here the x is not 1, too small. But when you put f equal to 2, you get 4. Then x is too big, 2 is too big. So the root should be, so since f1 negative, f2 positive, so have opposite sign, therefore the root lie between 1 and 2. So it should be 1 point something. That is what we are going to find. Okay, before that we are using Newton-Raphson. But now we are going to use the iterative formula. What we do here, the equation we can write in like this: x cubed equal to this, and then x equal to this. This is the iterative formula. Or we can also write like this: the 4x squared, we put it here, and then all this we bring over, so we write x as an object. So every time iterative formula, we change the x as an object. Okay, so you can change it like this, correct? Okay, or this one I can factorize x squared, I can take it out, the 20 I bring it over there, then after that I can find the x like this. Okay, so you can see all these are the iterative formula, and then or we can do like this. Okay, x I divide by x squared, x squared, x squared. So actually there are many ways, x squared, x squared, x squared. So after that we get this. So you see I have 4. But I tell you, during the exam they will give you, okay, they will give you either one. But here, in case they don't give you, they will ask you which one is suitable. That means which one of these will give you the answer, 1 point something. Which one will give you the answer? Okay, we know the answer is 1 point something, and then it's actually nearer to 2. Why? Because this is nearer to 0. I want to get 0. So the answer is nearer to 2, not 1. It's nearer to 2. That means it should be 1.8 something or 1.7 something. It's not 1.1 or 1.2. Okay? So which one of these is suitable? Which one of these can give you the answer? Okay? So how to know which one can be used to get the answer? So we do like this. What we do here, okay, this is another one. I divide by 3, this is another one. So I show you 5 altogether. This is another one. So which of these 5 iterative formula is suitable to find the root which is near to 2? Okay, so what we do here, okay, so I take the first approximation to be 2. So which of these 5 is suitable? So the iterative formula actually converge. Converge means can find the root that we want, which is near to 2. If you find the differentiation, you differentiate the fx, you get between 1 and 1. Then it will be suitable. Okay? So why is it like this? Of course, I can explain to you, but I think through YouTube or whatever is difficult. That one when we meet in the class, then I explain to you. Okay? So meanwhile, you just memorize. Okay, so you refer to the first one. See whether this is suitable or not. This one, the first one. Okay, the first one, the iterative formula is like this. So we let fx to be this one. So it's 1 over 3. So you differentiate, then you substitute the first approximation. I said it's near to 2. So you substitute 2, you see you get the answer is 2.117. 2.117 is not between these two, isn't it? That means you cannot find that means this iterative formula cannot find the answer, 2 point something. You cannot get the answer. You get something. The answer will run here and there. You cannot get this answer. Okay, Okay, so you see it does not converge to the root. That means the answer maybe is between, actually the answer is to 1 point something, and maybe the first time you try you get other value, and then the value will not converge. Maybe you will get 0 point something or negative 1 point something, but after that you get -2, -5, -6 like that. Okay, that is the meaning converge. Okay, and then you see the second one. Just now the second formula is this one. We see whether this one is suitable or not. Okay, the second one is like this. Okay, we also let fx to be this one, so we differentiate and then we substitute 2 because we know it's near to 2, as I said earlier. And you get a negative. This one is good. So it lies. Okay, so this one is suitable. That means this one it can converge to the root. You try, maybe I don't know how many times, maybe you have to try x1, x2, x3, x4, x5, x6, x7, then you will get the answer. Okay, you will slowly, you see, you will approaching the actual the value, the x, which is 1 point, very near to 2. Or number 3, we have this one just now. Number 3, this one, okay, this one. So you let fx to be this one, you differentiate, then you substitute. Okay, again you get negative 0.15. This one also between negative 1 and 1. So this one also suitable.